Hello everyone, I am teacher Aryanie.
I am teacher Julimer.
And I am teacher Rola.
We are fourth year students taking up Bachelor of Secondary Education, major in Mathematics
From the College of Education, Mindanao State University, General Santos City.
This is our video tutorial about special products of polynomials.
So at the end of our discussion, you are expected to identify and find the special products of certain polynomials. A polynomial is an algebraic expression consists of more than one or two terms, while special products are special forms of algebraic expressions whose products are readily seen.
A polynomial is an algebraic expression consists of more than one or two terms. X to the power of 6 plus 4x cubed plus 3x squared minus 7 is an example. A binomial is a polynomial which only consists of two terms. And a trinomial is a polynomial consisting three terms. While special products are special forms of algebraic expressions whose products are readily seen.
So there are four types of special products. First is the square of a binomial, the square of a trinomial, the sum and the difference of two terms, and the cube of a trinomial. So we will first tackle about the square of a binomial. So this special product is expressed as a plus b quantity squared or a squared plus 2ab plus b squared. So in your previous grade, you did this by using the FOIL method, which is sometimes very confusing to do. Using this special product will give you an easier and faster way in deriving to its product. So the pattern or steps in finding the square of a binomial is first, square the first term, then twice the product of the first and the last term, and lastly, square the last term.
So in the expression x minus y quantity squared, x is considered as the first term and y is considered as the second term or the last term. So we now have our first example, which is x minus 3 quantity squared. So the first step in finding the square of a binomial is to square the first term. In our expression, our first term is x, so we get x squared. Second is twice the product of the first and the last term. Our first term is x and our last term is negative 3, so we get negative 6x. And the third step is to square the last term. Since the last term is negative 3, we get 9. So finally, x minus 3 quantity squared is equal to x squared minus 6x plus 9. Our second example is x plus 5 quantity squared. Again, our first step is to square the first term, which is x, so we get x squared. Then, twice the product of the first and the last term. The first term is x and the last term is 5, so we get 10x. Then, square the last term. Our last term is 5, so we get 25. And finally, x plus 5 quantity squared is equal to x squared plus 10x plus 25. For a third example, we have 2x plus 7 quantity squared. The first step is to square the first term. So we have 4x squared. Second is twice the product of the first and the last term. Since the first term is 2x and the last term is 7, we have 28x. Then, square the last term. Our last term is 7, so we have 49. And finally, 2x plus 7 squared is equal to 4x squared plus 28x plus 49.
Okay, so now let's proceed to the square of a trinomial. The square of a trinomial is expressed as a plus b plus c quantity squared, or a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. So it is expressed as the sum of the squares of the first, the second, and the last term, twice the product of the first and the second term, twice the product of the first and the last term, and finally, twice the product of the second and the last term.
So a trinomial is consists of three terms. In this expression, x plus y plus z quantity squared, x is what we call the first term, y is our second term, and z is the third term or the last term. For our first example, a plus b plus c quantity squared. So the first step is to get the sum of the squares of the first, second, and the last terms, which are a, b, and c respectively. So we get a squared plus b squared plus c squared. So the second step is to get twice the product of the first and the second term. So we get 2ab. Third step is we get twice the product of the first and the last term. So since our first term is a and our last term is c, we get 2ac. And last step is to get twice the product of the second and the last term. So we get 2bc. And finally, a plus b plus c quantity squared is equal to a squared plus b squared plus c squared plus 2ab plus 2bc plus 2bc. For our second example, we have 3m plus 2n minus d quantity squared. So applying each step in this example, first we get the sum of the squares of the first, second, and last terms, which are 3m plus 2n and negative d, respectively. So we get 9m squared plus 4n squared plus d squared. So step 2 is to get twice the product of the first and the second term. We have 12m. The third step is to get twice the product of the first and the last term. We get negative 6dm. And finally, twice the product of the second and the last term. We get negative 4dn. So therefore, 3m plus 2n minus d quantity squared is equal to 9m squared plus 4n squared plus d squared plus 12mn minus 6dm minus 4dn. Now let's proceed to our third example. 2p minus q minus 5r squared. For the third example, first we get the sum of the squares of the first, second, and the last terms, which are 2p, negative q, and negative 5r respectively. So we obtain 4p squared plus q squared plus 25r squared. Then twice the product of the first and the second term. We have negative 4pq. Next is twice the product of the first and the last term, which is negative 20pr. And finally, twice the product of the second and the last term. We get negative 10qr. So finally, we get 2p minus q minus 5r quantity squared is equal to 4p squared plus q squared plus 25r squared minus 4pq minus 20pr minus 10qr.
Another type of special product is the sum and difference of two terms. So the product of the sum and difference of the two squares is the difference of the squares of the terms. In symbols a minus b multiplied to a plus b, it is always equal to a squared minus b squared. So always notice that the product is always a binomial.
So always remember that the product of the sum and difference of two terms is the difference of the squares of the terms. In the expression x plus y multiplied to x minus y, x is what we call the first term, while y is what we call the second term. So now let's get the difference of the squares of the terms. First is x plus y multiplied to x minus y. In this expression, the first and the last terms are x and y respectively, so we simply get x squared minus y squared. Second example, m plus 3 multiplied to m minus 3. So we get, since our first term is m and our last term is 3, we simply get the product of m squared minus 9. For our third example, 2p squared plus q multiplied to 2p squared minus q. See, the first and last terms are 2p squared and q respectively. We get the square of the two terms. We now have 4p to the power of 4 minus q.
We also have the cube of a binomial. This is expressed in the form of a minus b quantity cube equal to a cubed minus 3a squared b plus 3ab squared minus b cubed. To find the cube of a binomial, you must remember the following patterns. First, to find the cube of the first term. Next, thrice the product of the square of the first term and the second term. Next is find the product of the first term and the square of the second term. Lastly, find the product of the cube of the last term.
In this expression, x minus y cubed, x is what we call the first term, and y is the second term, or the last term. So our first example is quantity m plus n cubed. So first step is to get the cube of the first term, which is m. So we get m cubed. Next is thrice the product of the square of the first term and the second term. So we get 3m squared n. Next is thrice the product of the term and the square of the second term. So we get 3mn squared. And finally, the cube of the last term, which is n, so we get n cubed. Finally, we can now say that m plus n cubed is equal to m cubed plus 3m squared n plus 3mn squared plus n cubed.
For our second example, we have a minus b quantity cube. So the first step is to find the cube of the first term, which is a. So we have a cubed. Then, thrice the product of the square of the first term and the second term, which are a and negative b respectively. So we have negative 3a squared b. Then, thrice the product of the first term and the square of the second term. So we have 3ab squared. Then, find the cube of the last term, which is negative b cubed. So we can say that a minus b quantity cube is equal to a cubed minus 3a squared b plus 3ab squared minus b cubed. So for our third example, we have p squared plus q quantity cube. Our first step is to find the cube of the first term, which is p squared, so we have p to the power of 6. Then, thrice the product of the square of the first term and the second term, which are p squared and q respectively. So, we have 3p to the power of 4q. Then, thrice the product of the first term and the square of the second term. So, we have 3p squared q squared. Then, find the cube of the last term, which is q, so we have q cubed. Then, finally, we can say that p squared plus q, quantity cube, is equal to p to the power of 6 plus 3p to the power of 4q plus 3p squared, q squared plus q cubed.
So we're done with the 4 types of special product. As a recap, special products are special forms of algebraic expressions whose products are already seen.
So the 4 types of special products are the square of a binomial, the square of a trinomial, the sum and difference of 2 terms, and lastly, the cube of a binomial.
By following the patterns of the special products of polynomials, you will arrive with the answers easier and faster. You can even do it mentally.
So that's what special product is all about. We hope that we offered you a better understanding regarding this topic. Thank you!